we call a linear programming problem. I've kind of jotted down the pertinent information that we gleaned from the word problem, where I'm letting x equal the number of bushels of tomatoes, y equal the number of bushels of green beans. As far as tomatoes go, it costs $20 per bushel to grow, and you have to use 3 square yards of land. For a bushel of green beans, it costs $10 to grow a bushel. And as far as land goes, it's 6 square yards. So, and we have this amount of money available to us, $80, and we have 30 square yards of land. This is the objective function right here. The profit is what we want to maximize. So for each bushel of tomatoes, you have a profit of $40. For each bushel of green beans, you have a profit of $60. So 40 times x plus 60 times y will equal your total profit. And we want to know what combination of x and y will give us the maximum value for p. The constraints we can calculate like this. Since we have an $80 budget, it's 20x. That's the amount of money you spend to grow x bushels of tomatoes, plus 10y has to be less than or equal to 80. And as far as the land that's available, for tomatoes, you use 3 square yards, so 3x, plus for green beans, 6 square yards. And you only have 30 square yards of land. So the total amount of land that you use has to be less than or equal to 30. And also, x has to be greater than or equal to 0. You wouldn't talk about a negative number of bushels. And y has to be greater than or equal to 0. So there's your constraints. If you graph these two inequalities right here in the first quadrant, you get these two borders. And somehow we have to find, and so this region right here, linear programming theorem says that the maximum and minimum values of the objective function will occur at the vertices. So you have to determine what these vertices are. This 0.24 can be found by finding the intersection of 20x plus 10y equals 80 and 3x plus 6y equals 30. And I'll leave that to you to show that it's 2,4. And so we've got our 4 vertices, 0, 5, 2, 4, 0, 0, and 4, 0. You can't quite see there. There's the 4, 0. Whoop. Well, I erased that. So anyway, on to the next board. Here's the profit function as a function of x and y. I put 0 in for x, 0 in for y. I got a profit of $0. Didn't create any bushels of anything. At 4,0, the profit is $160. At 0.5, the profit is $300. And at 2,4, the profit is $320. So there is the combination of bushels and tomatoes. I'm sorry, of tomatoes and green beans that gives you the maximum profit, $320. So you want to grow 2 bushels of tomatoes, 4 bushels of green beans, and you'll maximize your profit. There you go.